In the previous video, we solved the first 4 exercises and numbers 5, 6 and 7 are left to you. They are quite easy. Today we start from 8. How many words with or without meaning can be formed using all the letters of this word equation if you cannot repeat letters? Let's first see the number of letters in this word. 1, 2, 3, 4, 5, 6, 7, 8. And as you can clearly see, no letter is repeated. So the answer is 8 factorial because the objects are distinct and we are taking all of them and forming arrangements. Don't keep the answer like this, okay? You calculate 8 factorial and you write the answer, the actual numeric value. Otherwise your marks will be reduced because this is India. Also, of course, you understand that you cannot write a short solution like this. You have to justify why it's 8 factorial. So whatever I said just now, you have to write those things as sentences. But anyway, let's see the next one. Number 9. In how many ways can we arrange the letters of the word Monday if the following conditions are satisfied? There are 2 other parts. Let's see part 1 first, where only 4 letters are used at a time. There are 6 letters in the word Monday, 1, 2, 3, 4, 5, 6, and all of them are distinct. So the answer should be 6p4. And here also you calculate the value and you write other things. Next part 2, what if all the letters are used? And the answer this time is of course 6p6, which is nothing but 6 factorial. And in part 3, we have to again use all the letters, but this time there is one extra condition that the first letter has to be a vowel. So you can see that this word has only these 2 vowels O and A, which have to be in the first place, any one of them. So the first place can be occupied in 2 ways. Once you have chosen any one of them for the first place, there are 5 letters available for you to choose from for the second place. And then for the third place, 4, then 3, then 2, then 1. I think I forgot to write something. That is that in this exercise also, in number 9 also, the letters should not be repeated. Okay, so that is also there. But anyway, so the number will be this, which turns out to be 240. Next, number 10. In how many of the distinct permutations of the letters of the word Mississippi do the 4 I's not come together? In the solution, we first calculate the number of possible permutations without that restriction that the 4 I's cannot come together. So first we see how many letters there are in this word. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 factorial, but some letters are repeated, so you have to divide. There are 4 S's, so you divide by 4 factorial. There are also 4 I's, 1, 2, 3, 4. So again you divide by 4 factorial, and there are 2 P's. So you divide by 2 factorial as well. So this is the number of permutations of the letters of this word without any restriction. And we have given it a name also, say N1. Now from this we are going to subtract the number of those permutations where the 4 I's occur together. And that number can be found like this. You have already seen this type of things. So what we do here is that we keep those 4 I's together and treat that itself as a single letter. And then we arrange the letters, where the other letters are treated as letters, but this is treated as one unit or one letter. So as you arrange these objects, this itself moves completely. So now how many objects do you see here? 1, this is only one object, 2, 3, 4, 5, 6, 7, 8. So 8 factorial. Divided by, you also have to take into account how many of the objects are repeated. There are 4 S's, so you divide by 4 factorial. Still you have 2 P's, so you divide by 2 factorial. But then you also take into account how these things inside that single object, which you are treating as a single object, arrange among themselves. There are 4 objects here, so you write 4 factorial. However, here also there is repetition. So you have to take care of that also. Because all of the 4 objects are the same, so you divide by 4 factorial, which ultimately turns out to be 1. So whether you rearrange those i's or you don't rearrange them, you are not going to get anything extra. So that is why ultimately the effect is just having 1. But anyway, if you write like this, it shows that you know what you are doing. So that's how you get n2, and the answer would be n1 minus n2. And finally we have number 11. It has 3 parts. In how many ways can the letters of the word permutations be arranged if the following conditions are met? The first one is that words start with P and end with S. For example, like this. This one itself starts with P and ends with S. If words have to start with P and end with S, that means the first and last letters are fixed. You can only arrange the intermediate letters. So let's see how many of them there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you write 10 factorial. And among these letters, you only see T appearing twice. No other letter is repeated. So you divide by 2 factorial. That's the answer to part 1. In part 2, the condition is that the vowels have to be together. The vowels have to be together. So you take all the vowels from this word and put them together. It turns out that you have all these vowels here in this word. A, E, I, O, U. And the rest are consonants. So this is considered as one unit which will move as you arrange these objects. The others are treated as separate units, okay, the other consonants. Now, how many objects do you see here? 1, 2, 3, 4, 5, 6, 7, 8. So 8 factorial divided by, there is repetition, T appears twice, so you divide by 2 factorial. And then you take care of those things inside that box which you are considering as a single unit. They can arrange themselves in how many ways? You have 5 distinct objects here, and taking all of them together, they can arrange themselves in 5 factorial ways. So you multiply by 5 factorial. And finally part 3, where there are always 4 letters, exactly 4 letters between P and S, that type of words. There can be 4 letters between P and S in this way. There are other ways also, and we will consider them, but this is one of the ways. It starts with P, then you have 4 letters, then you have S, and then you have the rest. Because it's cumbersome to keep drawing those boxes, so instead I am using asterisks. And the total number of such words is 10 factorial divided by 2. Why? Why is it the same as part 1? Well, in part 1, the first letter was P and the last letter was S. Okay, they were fixed. Besides them, there were 10 letters and you have 2 T's. So that's why the number was 10 factorial divided by 2. The same thing happens here, not exactly the same thing, but the similar thing happens here, because now P is fixed here and S is fixed here. So you can only arrange these others, which are 10 in number with 2 T's. So that's why the number is 10 factorial divided by 2. But this is of course not the only way in which you can have 4 letters between P and S. There are other ways, and now we are going to consider them. These are the other ways. Actually, these are also not all the possible ways, but these are some other ways. Instead of starting the word with P, you can have 1 letter before P and then 4 letters after P, then S, then the rest. And you can shift this PS part rightward. and finally you reach this where S becomes the last letter. And in each such way means, for example, if this is the structure of the word, then there are this many words available for you that will have this structure, and where the rest can be arranged. P, however, appears here and S appears here. So each of these ways gives you this many permutations, and they are all distinct. And how many ways do we see here? 1, 2, 3, 4, 5, 6, 7. So 7 times 10 factorial divided by 2 factorial. But what is this 2? This 2 comes because you can also have SP. S comes first, then followed by 4 letters, and then P comes. Because it's not said in the question that P has to be the letter which comes before S. S can also come before P. So that's why it will be twice this number. So this is your final answer. And here the exercises end and permutations also end. In the next video on these things, we are going to start combinations.